Good evening, everyone, and good afternoon to Professor Marco, since he's joining from Switzerland and it's around 12 p.m. there. Um, this event is actually organized under the aegis of Internal Quality Assurance Cell of Shaheed Bhagat Singh College, University of Delhi, in lieu of India's AI Summit, which is to be held later this month. For the introductory remarks, I now hand over the mic to Professor Varinder Kumar, who is the IQAC coordinator of Shaheed Bhagat Singh College. Over to you, sir.
Okay, thank you, Pratyush. Very good evening to all of you, all the participants. Our keynote speaker of the day, Professor Marco Steenberg, my dear colleagues and students who are attending this talk. I extend a formal welcome to this online workshop titled AI and Social Science, Promises and Pitfalls. I am Dr. Varinder Kumar, Professor of Mathematics, Department of Mathematics, Shaheed Bhagat Singh College, and Coordinator IQAC. And it is an honor to inaugurate these proceedings. As Pratyush just mentioned, that India AI Impact Summit 2026 is announced by our Honorable Prime Minister, Mr. Narendra Modi, at the France AI Action Summit, and it is scheduled for February 19th and 20th, 2026 in New Delhi. And it will be the first ever global AI summit hosted in the Global South. And these are the pre-conferences and workshops that we are doing to enlighten our citizens with the benefits and prompts and whatever things we can do and what benefits we can obtain from it. As artificial intelligence permeates diverse domains, its confluence with social science, encompassing sociology, physiology, and all other branches of humanities like economics and anthropology, presents transformative opportunities alongside critical ethical imperatives. This workshop examines AI's role in advancing research methodologies, quantitative analysis, policy design, and institutional frameworks. Our program is structured for efficiency. We are privileged to feature our keynote speaker, Professor Marco Steenberg, from the Department of Political Science at the University of Zurich. Professor Steenberg specializes in political psychology and social research methods. His insights will anchor our discussion, followed by a brief interactive session and question answers. And the program will be shared in detail with by Mr. Pratyush. I am sure all the attendees will benefit immensely from the knowledge shared by our speaker, and my sincere appreciation to all the attendees. I hope all of you will be benefited from this talk. Thank you very much. Over to you, Pratyush.
Thank you, sir. Now, moving forward, I'll just go through the profile of Professor Marco Stenberg. And as we already know, he's from Department of Political Science, University of Zurich. He studied political science at the University of Amsterdam and Stony Brook University, USA. He's a specialist in political psychology and social research methods, as also mentioned by Professor Varinder. He is currently professor of political methodology at the University of Zurich, and he has previously held positions at Carnegie Mellon University and the University of North Carolina at Chapel Hill and the University of Bern. His research focuses on ambivalence, democratic theory, American and European politics, and social statistics. Also, I would take the opportunity to mention that he was also a part of second Indo-Swiss Research and Methodology Festival organized by ICSSR in collaboration with Swissnix and the University of Basel, which actually ended on 7th of this month only. Professor Marco, I now hand over the floor to you. Over to you, sir.
Okay. Um, can you see this?
Yes, sir.
Okay. Um, so I don't want to give the talk I gave last week because Pratush was already heard that one. So I actually focus it a little bit differently this time. And maybe also a little bit broader than just social science research, but more research in general, I think. And the the premise of the talk is actually a quite simple one. So AI has the potential to change science, what we investigate and how we investigate. I will focus more on the how we investigate aspect. But of course, AI increasingly now also is a topic of social scientific study, of philosophical inquiry, of psychology increasingly. Um, and so we study it, but also the way we study um, actually pretty much any topic these days is very heavily now influenced by AI. But my argument will be, and I think this is not always so obvious to people who use AI, is that we as scientists also affect what AI is, and probably should do that because it's probably the only way to get to a responsible, culturally sensitive way of doing things. So I'll give you a little bit the AI basics without going into too much technical detail. But just as a background to what I will be saying in a moment. So AI, as we know it these days, I think is very much a a methodology that is rooted in large language models. And these large language models are effectively predictive text machines, very sophisticated predictive text machines, but text predictors nevertheless. So what they actually do is very much sort of come up with the next most likely word based on the context that we provide. The nice thing is that they're actually very sensitive to that context, although various models have different capacities for more or for less context. And what is important to realize is that these LLMs don't act on a ground truth, but on probabilities that are informed by a vast knowledge base that is growing all the time. And of course, the prompting that is done by the user. That's a very key aspect to what we're doing there. Now, large language models are extremely powerful, strong, and at the same time, they also are quite weak in spots. Basically, what they do is they build on representation of data, text in this case, most of the time. That's changing, but for now, it's still predominantly text. And they make these representations with many, many parameters. When we sort of think about this, we're now looking at models with billions of parameters. These representations, this is important to understand, these come about in part because computers actually don't understand text, so they need to interpret text, and the way computers interpret text is as numbers. So we need to first convert that text into numbers, do that in a context-sensitive way, and that's what happens in these large language models. And these representations of text, they are based on vast amounts of training data, books, articles, code, websites. This is one area where these models get more sophisticated all the time. They ingest more and more knowledge. At the same time, that's one of the places where they become more powerful. And the other place where they become more powerful is that the number of parameters grows by the minute, it seems at times. And a great advantage is that they can operate at scale and at a very high speed typically. that means generally what we can do is we can actually um, let them complete tasks in a relatively short period of time. Not completely free, by the way, because there are environmental impacts of all the queries we're sending. And of course, many of the platforms that offer AI to us charge hefty premiums at times. But but I mean, in any case, much faster and probably still a little cheaper than it would be otherwise to complete these tasks. And some would say also with greater accuracy. Um, Although that depends, as I will explain in a moment, quite strongly on the way we actually prompt the AI. Um, what comes out of these AIs are probability distributions over the next word. And typically, the logic of many of these uh, platforms is that they then report back the most likely next word that they've come up with. So what they're doing is they're ingesting text, they're ingesting prompts, and they convert that into probability distribution. And what we then see is the most likely text or response that to our question. So here is why, despite all of this power, I would argue they're also quite weak in some ways, because the LLMs are only as good as the data they are built on. So what is missing in the data can potentially be improvised, but the result is then typically a hallucination. A hallucination is the AI comes up with an answer, but it's a nonsensical answer. For instance, probably the best known example of hallucinations is that the AI comes up with a citation that simply doesn't exist, or is some form of a combination of things that do exist but put together in such a way that a non-existing entity is displayed. Uh, the other thing is that biases in the source data will get amplified. So if certain knowledge is not there, if there is silence, then the AI is actually generally not going to come up with ways to overcome that silence other than perhaps the hallucinations that I mentioned. And if there are over and under representations of patterns in the raw data, then it is likely that we will also see that in the outputs that are generated in the process. So this is all, I think, important to realize, because sometimes we sort of tend to think about the AI as this magical toolbox that just conjures up the most remarkable responses, but actually the machinery behind it is very complicated. Mathematically, though, not even that complicated. It's basically a chain of predictions that then where weights are assigned to the different paths in the chain, and then they're updated through something that's called backpropagation. But backpropagation is essentially an application of the chain rule of calculus. So this is not really all that complicated. Now, I think it is very important when we look at this AI to sort of strike a balanced pose, because what you often see is sort of two extremes: the utopian hopes and the dystopian despair. Not either people think that AI will solve all of our problems, or they believe that it is the end of civilization as we know it. And I don't think it is either of these things. there is only so much that AI can do well. And while the potential grows by the week, you have to really be realistic about what it can do at this particular point in time. So utopian hopes are, I think, misplaced. But at the same time, the dystopian despair is also, I think, a little bit exaggerated because AI will not kill research or take over researchers' jobs yet, anyways. And we are still in control, although it has to be said that some bright minds that have contributed to the development of AI, like Geoffrey Hinton, have come out and have sounded the alarm clock about this control. But I think at the moment, anyways, we are very much in control. And my story is actually always with AI. We must be in control. Otherwise, it's not going to do us very much good in research. Now, the other thing that I want to quickly point out is that one should probably carefully choose the AI for a purpose. AI is often sort of made synonymous with ChatGPT, but that's of course only one of many different platforms. And ChatGPT has its strengths, general reasoning, writing. It's actually quite good at social science tasks. It has a large ecosystem with plugins and all of these things. But the training is a bit opaque. The weights that are all these parameters that I mentioned are not public information. It can hallucinate with quite a bit of confidence. And it doesn't really do so well with very long documents. And versions change, and then it's very difficult to replicate what one had from the previous version. I like to use that for exploratory theory work, for some research design, for coding, it's actually wonderful. But for other areas, I would myself move to other examples. So Claude is one that I use fairly frequently that works quite nicely with long text. It is quite cautious and norm aware. It preserves nuance that's particularly important in qualitative research. Um, I mean, Claude is one of these platforms where the company, Anthropic in this case, really goes out of its way trying to debias the database. The ecosystem is not quite as developed, but here I would say, I mean, I would use that more for qualitative analysis. I didn't do that last week in the workshop. For close reading and for ethical questions, all of these things I think that can be better handled in Claude. Gemini is very much tied into the Google ecosystem, is particularly strong for multimodal data. What I mean by that is data that actually are of different varieties, not just text, not just images, not just video, not just audio, but a combination of all of these things. This is a growth area in AI. It's an important growth area in AI, and I think it's particularly important growth area outside of the social sciences. I'm thinking here of medicine, for instance, but could also be a very important growth area for the social sciences. We have a lot of multimodal data. Then there is Llama. That's, of course, from no, I'm blanking. I can only think of Facebook, and it's no longer called that. Meta. That's and that is particularly good because that insists on showing us all the weights. It's an open source, but if you want to fine tune these things, if you want to fine tune these weights, then you basically need to have quite powerful computers. And it has some disadvantages. So, for example, a safety layer there, which sort of takes into consideration sort of the normative propriety of certain answers would have to be added actually by hand. I've used it less than the other ones, but on occasion I've done it because it actually does have some nice applications in methodological research. So what I would like to do is now, sort of, now that we've seen a little bit of background, I would like to split it up into two parts. I want to look at the effect, the influence that AI has on the way in which we conduct research. That's the first part of the talk, and also perhaps the longer part of the talk. But then at the end, I want to reverse the arrow and go from the way we think and do research to what that can do to improve AI. And AI has tremendous potential to change the way we conduct science. And I actually don't usually start by saying it improves our efficiency. I actually start by saying that it sharpens our thinking. Because I believe firmly that for AI to be useful at all, beyond trivial tasks, and research is typically not a trivial task, we need to think very carefully about what we task the AI with. But of course, it also increases efficiency. It will complete tasks in a way that I think we would not have been able to do even 5 years ago. I mean, you have to keep in mind that what we're building on here is basically not that old. So the language models that have sort of led to the AI, particularly the idea of transformers. The fundamental paper on that was published in 2017 by Vaswani et al. And so that is less than 10 years ago, and it has taken us very, very far. And so when I say, yeah, 5 years ago, we would not have actually even dreamt of some of the things we can do with the AI. That is because the technology that we build on now is not that old, but has evolved very quickly. So I also very strongly believe, though, that all of that potential depends on us staying in charge as researchers. So I dub that here as HALE, human always in the loop AI. But this is the idea that we are responsible in the end for whatever we do with the AI, for whatever we do with the outputs that the AI generates. We can ignore those outputs, we can accept those outputs, but the buck stops with the researcher. And that has sort of very variety of aspects to it. So the humans, as I already said, take the ultimate responsibility for the research practices that they follow. We also, secondly, should really start to pay very close attention to how we prompt the AI. And here I tend to think that prompting really is thinking. It's thinking about our research, obviously in ways that can steer the AI into a productive direction. But if we haven't thought about our research and we just formulate some kind of prompt to the AI, we will get an answer, but it will probably not be a very helpful answer. It could even be a misleading answer. It can actually send us in false directions, thereby mitigating some of the efficiency gains that we could have had. So we need to think, and the thinking then is translated in the questions that we ask, the boundary conditions that we give to these questions, like in what context are we doing our research? What is the population we're working with? These kinds of things, they become actually important, and they require us first having thought about things. Finally, what I think HALE should mean is that AI must also be scrutinized. I like to put it this way: if you accept the first answer that AI gives you, then you have outsourced judgment. If you ask the next question based on that output, you do research. And I think that's what you actually need to do. And sometimes, and this is actually one way to get beyond these, get around these confident hallucinations, is to simply ask AI the question, okay, are you really sure of that? Because sometimes actually then the AI will come back and say, well, maybe not. Um, so let me then talk a little bit about some very specific places where the AI can contribute to science. And I've done this here now in this sort of setup of the sort of research cycle that we often teach our students in the social sciences. I left out one step there, which is the research question step. I still think that the research questions really are ultimate responsibility. I think research is about asking good questions. Not, I mean, this is a quote that is sometimes attributed to Levi Strauss, sometimes to Albert Einstein, but more than the answers, perhaps even the questions we ask are what drives good research. And I would not want to outsource that to AI, at least not yet. So my research cycle actually starts then in the next step with the literature that we usually then end up looking at. So where are the gaps in the literature? What do we know? What don't we know yet? Then we typically develop some theoretical argument out of that and hypotheses that go along with that. Then we develop a research design where we then develop a strategy, a plan on how we can answer a research question, how we can test our hypotheses, perhaps how we can see whether our theory has some merits or whether it really is inconsistent with the data. We can then, in a next step, look at data collection and measurement. Then once we have the data, we can look at the analysis, and then we have, of course, the important step of communication. And in all of these 6 stages, AI can play a very beneficial role, assuming that it is handled right, is handled responsibly and ethically. So let me just break down these various steps and start with the literature, because this is probably the place where we often go first, not with the AI, is to sort of canvas the field. What is known already? This is part of what used to be very hard labor in science. Not you would stay up with the literature, you would go back with literature and so you would have to spend a lot of time, well, first in libraries and then later in online with things like Google Scholar. This has all become much easier, and so I typically sort of have a couple of tools that I rely on for various parts of the process. So if I just want to see what is out there, I might use Semantic Scholar or Connected Papers or OpenAlex to sort of see what is being written on a topic. If I really want to sort of start thinking about a literature review, then Elicit and Rayen actually are quite nice tools. I have more experience with Elicit than with Rayen. But Elicit, for example, will will provide synthesis of the literature. I mean, it has a bit this aspect of this side says this, the other side said this, and the truth is somewhere in the middle. That's often what you get with the AI. So um, you need to be very careful in how you interpret that. If you want to go really deep, then Claude and maybe ChatGPT, but especially Claude, are very good for that. And what I increasingly start seeing, and this is actually, I think, quite an important aspect of the whole thing, is the systematic reviews and the meta-analysis aspects. So science produces lots of studies, different fields. It is sometimes incredibly difficult to keep up, let alone to give a very good impression of where the state of the knowledge is. And so platforms like Covidence actually help you with that. But there has been a real sort of flurry of work as of late in sort of trying to see how we can actually improve these kinds of large-scale literature reviews, which are often extremely important, not because, for instance, I just got done reading a grant proposal where someone was looking at, okay, what do we know about various climate policy initiatives at the urban level around the globe? So how efficient are these policies? Well, there are so many of these initiatives, and there's so many studies of these initiatives in all sorts of languages that it is incredibly difficult for a single human or even a small research team to really get a good sense of what we know, and also where to stop looking at the literature, because we sort of feel that we've already know the answer. And there is a literature evolving there with various strategies on stopping, that actually help us to understand what then, for example, these effects of these policies are. Which policies are effective, which ones are not effective? What is sort of roughly the effect size? Uh, that's what are the negative side effects of some of these policies. So these are the things that actually are important. But at the bottom of this slide, I once again have just sort of reiterated a refrain that you will hear a lot today, which is the human judgment remains central. This is this idea that the human should always stay in the loop. Now, theory is another place where I often feel extremely uneasy about relying too much on AI. Um, oh, so that was my AI doing something random here. Because I think theory remains a deeply human process, how we arrive at theories. And sometimes it's also a process, especially in qualitative research, where we don't start out with a theory, but the theory is sort of the product that evolves as we are doing our research. But there are some tools that can help us in that process. Again, help is the key word here. They don't substitute for us. They don't replace us as researchers, but they can help us streamline the process. So, for example, Storm is a tool that sort of tries to sort of extract theoretical ideas from text. So that could be actually quite interesting if you sort of start by writing just a sketch of what you think is happening, what is actually explaining a particular phenomenon, then Storm can help you to sort of sort that out. Tong et al. In the psychology literature do something even more specific. They extract hypotheses from literature. Um, and that's of course quite useful, not? I mean, but what you have to be careful with some of those applications is that, of course, you're not likely to come up with a revolutionary new hypothesis this way. What you're going to probably get out of this is something that is rooted in the existing knowledge base. So big scientific revolutions are not likely when you go do this. There's a lot of work emerging on causation, which is, of course, a very crucial part of science, increasingly also of social science. And here too, again, the AI can help us. So, for example, there's a very nice paper in Medicine by Gopalakrishnan that sort of shows how we can create a text and then we can actually extract a causal argument out of that. And that helps us perhaps sharpen our thinking a little bit, because it will also show where perhaps the mechanisms are not quite spelled out, where the causality is a little bit problematic because, for instance, it could go both directions. Counterfactual causation is very important. I mean, so going back to Jerzy Neyman and then later Donald Rubin, sort of what we call now the potential outcomes framework of causal inference, is based essentially on counterfactuals, and that's something where people have done work. There's a very nice review by Liu et al. That speaks to that. So that's important. Now, where I actually start to see the benefits, particularly though, is once we get out of the theory side of things. Not so the literature side helpful, the theory side, I'm always a little reluctant to relinquish my autonomy there, but other people are less worried about that. But once we get to the research design, I think actually the AI becomes very potent again. And so what I sort of see as four nice places where we can use the AI in our research design is, first of all, to do design prototyping in light of disciplinary norms. So we can ask the AI, okay, here's my research question, here is my hypothesis, here is the key independent variable, here's the outcome I'm trying to understand. What kind of designs could you come up with? And I could then give as a boundary condition, judge how that would fly in my discipline, because we are unfortunately bound to these disciplinary norms, not? And if we sort of end up doing things that are somewhat odd in our discipline, then the chances of getting published, of course, are diminished. Now, working in the domain of natural science, Nolte and Tom Forday have written this really nice paper about design simulation. So here we're looking at AI simulating data generating processes under our stated assumptions. So we say, we think the world works this way. And now tell me, okay, what would the data generating process look like? And what kind of sample size would I need to achieve sufficient statistical power? How do I avoid bias? What are the estimates, the things that I want to actually quantify? What do they look like? And I haven't seen many applications of this yet. It's also a very recent paper, but I think that holds a lot of promise. What is really not very well explored yet, but this is something I'm working on, is actually using the AI as an adversarial stress testing ground. So I basically say, all right, here's my research design. So now give me some plausible failure scenarios, because what we often sort of end up doing to preempt these failure scenarios is that we run a pilot study, not, and then we see, okay, where does the ship strand and should we have done differently? But if we do that too often, these pilots are also not cheap to run. And so it's better to actually take one step back and to say, okay, let's just see what can all go wrong plausibly. And then see, okay, maybe I should be careful here in my design, because something could be not work the way I would like it to work. And an extension of that is the sort of worst case and boundary exploration. Not I can ask, okay, the I can ask it, what are low probability but high impact breakdowns? What happens if, for instance, I run this beautiful experiment and there is massive non-compliance with the experiment? Um, I mean, there are such experiments. In my discipline of political science, people like to use this idea of voting advice applications where voters go onto a website, they give their opinions about issues, they are contrasted with the views of the parliamentarians, the parties, and then they get an advice of which party is closest to them on the issues. But the problem is that people self-select into these kinds of platforms. So there were experiments where people tried to randomly assign, but of course you can't force people to use the platform when you'd wanted them, and you can't tell control subjects either that they are not allowed to use this platform. And so what happens inevitably at the end is then that the compliance is really miserable. And when you then do causal inference with something like instrumental variables, you basically get an estimate that is relevant for a really, really tiny segment of compliers. Now, that brings me to the AI in data collection and measurement. So I have used personally AI for stimulus generation. So sometimes I run experiments where I want to manipulate an image, for instance, highlight something in the image for some group individuals in the experiment and not for other individuals. AI is very good at that and getting ever better at it. And what is nice about it is that you can be very precise about what should be manipulated and what should be held constant. And so I've seen applications of that, for example, also in studies where actually this is for especially in the United States, where the skin color of a political candidate is then used to see whether white people are inclined to vote for that person. Uh, Quite controversial research, but that's one place where you get that done. Um, what I like to do as well, although I haven't done it a lot because I haven't lately been running many cross-cultural surveys, is to actually use the AI for survey translation and cultural adaptation. So, I mean, in comparative survey research, and there was a lot of it, for instance, the World Values Survey, we tend to ask these questions in many different languages in many different countries. uh, to obtain a view of public opinion or of people's ideas in various cultures and places. Now, the standard way in which we sort of have always done this, which is quite expensive, is to sort of translate it into the other language and then back translate it into the original language in which the question was written. And then we hope that we get more or less back what we started out with. That's actually quite good when it comes to sort of the linguistic aspect of survey questions, but it doesn't really get so well at the cultural sensitivities, which vary vastly and have severe consequences. Because if you ask a particular question that is, for example, socially undesirable in a particular context where certain responses are not spoken out, you're going to get massive differences in how that measurement instrument varies, is used in different cultures. And you don't know in the end anymore whether differences you observe between the cultures are real differences in the thing you're interested in, or differences, artifacts of different ways in which people use the scale. We use this for automated measurement of latent constructs. So you can think about ideology, moral foundations, sentiments. You can add on to that list that you can base on text, speech, and also on images. This is an area where I think there's been a lot of growth. So in my world of political science, I mean, for instance, party positions are increasingly being measured based on just whatever ChatGPT thinks these parties are doing. AI-generated data are the fourth place to where we can basically not so much improve measurement, improve data collection, but actually even substitute it in part by actually using synthetic respondents or synthetic units like simulated patients or digital twins, depending on the area of study. This is increasingly common too, not just in the social sciences. I've been told that actually certain areas of science really can't do without this anymore. It's actually something that I think works to some extent because, I mean, data augmentation, you could think of it that way, is fairly common in, for instance, Bayesian inference. The problem is, particularly with synthetic survey respondents, is that, of course, what we do is we base the behavior of respondents who have answered questions in the past, not. Now, those might actually already be very atypical subsets. So if we want to say something about public opinion based on artificial respondents, we have to be very careful because the typical survey that informs these synthetic units is not always representative of the population. So that's where we have to be very careful. So again, human judgment, very important there. Then let me get to the last two bits here. So AI for analysis, I've broken it down here into qualitative and quantitative. So qualitative, coding, classification, thematic discovery. That's something I practiced with the students in the workshop last week. So we detect topics, frames, discourses about something. The risks there include the hallucinations or the overgeneralized themes where we end up sort of losing a lot of the detail and also a lot of the context. Sometimes we close things prematurely, where further scrutiny of the text would have actually taken us down other paths. We use this also in comparative and cross-case analysis, so structured comparisons across cases, groups, time, whether risks are things like false equivalence, ignoring case-specific meanings. So these are things we have to be aware of and pay attention to. In quantitative research, what my students love to do is to just farm out anything statistical to ChatGPT and then not worry about it anymore. So this is what I call model assistance and workflow automation. So let ChatGPT decide on the model specification, on the code, on diagnostics, and debug when there is a problem in the code. Um, well, sometimes unnoticed assumptions creep in. There is an automation bias. And in general, what I've discovered is that if you don't know anything and you try ChatGPT and you make ChatGPT try to do the analysis for you, it's often not the best result. You need to also there know something to optimize the use of the AI. I went too far. The other place, of course, is machine learning and prediction. Not very nice if you have high dimensional predictions where we are looking at potentially thousands, even hundreds of thousands or more potential predictors, where we don't know how these predictors interact, whether there's non-linearities in their effects. This, of course, also is the whole area of embeddings of text, where we take the words and turn them into numeric values, like I explained earlier. And here you just need to be aware of the fact that we can easily overfit. That is, we typically in that kind of work split the sample into training and test sets, and we train with the training set, and then we try to predict based on the estimates and the other parameter settings from the training set. We try to predict the test set. Sometimes when there is overfitting, you will find that that test set doesn't really lend itself very well to prediction, because we basically have tried too much to account for the patterns in the training data, and they just simply don't generalize. And the other thing that we need to be aware of, that prediction is not explanation. We can come up with perfect predictions that nevertheless we actually don't know much about. So I'll end this part, and I promise the next part is going to be faster, with a little bit on the communication. And this is also another controversial side of where we have AI influencing our research, because a lot of editors of journals are not happy with AI providing text, because the questions of who is the author, is that plagiarism, and lots of other ethical questions that come up about ownership. My personal advice here is don't let AI do your writing. It's simply too risky, and it also is a bit boring. I mean, I know that we have become very standardized in our writing in most disciplines, and you basically learn how to write a paper with all the right sentences, but the little bits and pieces that are still our own, I think, make the difference between having to read 5 papers that are almost exactly the same in their style and having 5 papers where there is some nice personal touches. That doesn't mean that we should avoid AI altogether, because I have used AI, for instance, to suggest how I can communicate more effectively, because I tend to write probably more sentences than I should, or longer sentences than I should. am sometimes a bit repetitive, and the AI will spot that and can help me then sort of navigate around that. Um, it can also help us to sort of figure out, okay, where does the argument, flow of argument not really work because you've omitted something crucial? Or where are you contradicting yourself in the text? Doesn't happen very often with me, but occasionally I end up changing my ideas a little bit in the writing, and then there's still some remnant of an old text that doesn't really quite fit to the new text. It can help us optimize visuals, which is quite important because visual communication is what I think does a lot of the work in research. And it can also help us to create some checklists. That's very nice for thinking about pre-registration of research, for data management plans. It can even help you with the ethics approval process, as long as it is just creating the checklist and making sure, okay, have you thought about all possible ethical aspects? And that brings me then to the key lesson here. The researcher is the final arbiter of everything. AI should aid our thinking, it should not substitute it. And AI made me do it is not an excuse for bad, ethically questionable, or irreproducible science. We need to be very careful about that. Now, if you allow me, I would like to now speak a little bit to the other way we can think about the relationship between research thinking on the one hand and AI. So we've talked about how AI can help us in our thinking and our research, but I'd like to also emphasize that the way we think and research will guide AI. It almost naturally does, because the things that we publish now will become eventually part of the corpus on which AI models are trained in the future. But there are actually some other dimensions to that. I think, in a sense, this is just a recognition of something that I think is very well known in philosophy of science, which is that methods and theory tend to co-evolve. Not statistics reshape social science questions. Survey methods reshaped concepts like public opinion. Experimental design reshaped our way of causal thinking. And AI is simply the newest iteration in that loop, albeit a very potent one. And I think that's important because I think it is, I think, healthy to think of this AI research connection as a symbiotic relationship, maybe not even a symmetric relationship. Now, how does our research inform AI? There's a couple of different ways to think about that. First, we could think about conceptual, not? I mean, we provide concepts. As we learn about the world and we start categorizing phenomena, we create concepts to do that. So a phenomenon is, for instance, reflective of a social identity. And social identity is one thing, and that distinguishes that concept from other concepts we might use in psychology. And that distinction allows us to then, for example, in psychology, separate attitudes from beliefs. Um, it also helps us to define failure modes. So, what should we be aware of? Confounding, bias, concept stretching, that's important. Methodologically, we actually provide evaluation benchmarks, not? What is actually a good prediction in my discipline? And that goes then even further to the normative question of what counts as good science. And related to it being good science is then often also some sense that findings are robust. So what are then the robustness criteria? This is not something that AI learns on its own. I mean, this is what we collectively as researchers put into our disciplines, into the papers we write in those disciplines, that then becomes the training data. Normative questions, because AI doesn't understand norms the way we as humans do. So what is harm? What is fairness? What is truth in my particular field? Those are all things we're giving back to AI without us even knowing it. But we can go much more deeply with that. AI systems learn from what exists in digital form, not from what exists socially. And research often determines what becomes legible and archived. And I had a great example of that last week in my seminar where someone said, yeah, I actually tried AI to do something and it just kept giving me nonsense. And then I realized it just didn't have the data. So this person provided it some of the data, and that then became the raw material that allowed the AI to actually produce reasonable and informative answers. So I think this is actually particularly important, perhaps in a place like India, because large parts of Indian society, I am sure, are underrepresented in English language corpora. And they may even get flattened into stereotypes. And this is something that needs to be corrected desperately, I think, for AI to do what we want it to do. So, to put it simply, AI informs research by expanding what we can see, but research informs AI by determining what gets seen at all. And that brings me on to an even bigger topic. And I thought about this for a while, and I have seen very little on this, but this goes into questions of epistemology. AI makes assumptions about knowledge, and it does it mostly based on Western analytic views. So, knowledge, for instance, is equated with propositional content. Language is the primary carrier of knowledge. Truth is defined as correspondence or coherence. Reasoning is symbolic or statistical inference. It's logic or statistics. Or math. This is all perfectly fine, but different societies have different understandings of what knowledge is. And the way I understand Indian philosophy is that it actually has many distinctive ways of thinking about knowledge. So, sorry about that. Oops. So, for instance, perception, inference, testimony, experiential realization. It doesn't always have to be propositional either, not. And I think that is very important for us to actually start realizing, perhaps. And this brings me then maybe a bit of a controversial slide, but I am increasingly of the mind that we should build perhaps local AIs. And that's not just for safety and for data privacy issues, but local, I mean here, not you put your own server and you run your local large language models just there, but I think actually keep what is useful, but add what works in your society. So think about, for instance, reasoning in context or valuation of dialogic corpora, not just encyclopedic knowledge. Disagreement, depending on your society, can mean different things. Not disagreement can sometimes be noise. It can sometimes be a signal about real differences of interpretation. Sometimes tradition is a very crucial part of a society. And the question is, should we not also give that some space within the AI so that it takes that into account in the answers it provides? And ambiguity is something that we often like to avoid in Western philosophy, but in many places, and I think India is actually one of them, it is actually considered to be an inherent fact of life and of science, perhaps. And so we need to think about building AI with our goals in mind. When we use the AI, we need to also think of those goals. We need to think. That's the ultimate lesson in this whole story. AI should never be treated as an automaton that will just bring us wonderful things at no cost. And we can all have extended holidays as scientists because the AI in the background will do everything for us. When we come back from our holiday, there's a paper that we can submit to a journal. It's not how it's going to work for us. How it's going to work for us is that it helps us to reshape our workflows. There are some tasks that tend to be very time-consuming, medial, and error-prone, where the AI can very easily take over. There are other tasks where the AI can help us in our thinking, but ultimately it's our thinking, it's our research, it's our product. We have the ownership, we have the responsibility. We need to be the ones that stand behind what we have generated. I spoke way too long, but I'm happy to take questions.
Thank you, Professor Marco, for the quite enrichful presentation. It somewhat reminded me of your last week, in fact. Uh,
Yeah,
we have several questions in the chat.
yes, I saw a number of them. That's right.
Yes, sir.
Uh,
You can see in the chat box, so maybe you can take a
yeah,
look there.
let me quickly get out of this. I'll stop sharing and then
Sure.
yeah, then
In
I
case
have
if
the
you want, I
chat.
can read it out for you as well.
Okay. So to what extent can AI models be trusted for policy-related research, say systemic risk assessments, or maybe of banking, for instance? So that's a very good question. I think, and it very much, I think, follows this logic that I had in mind. Not so. We have to be very. We can get a lot of policy relevant information from AI. So I mentioned earlier, for instance, this question of local environmental policies and whether they're effective or not. And there the AI can really do a lot. And there's actually some wonderful examples in that literature of these systemic reviews really showing us, okay, what can be done, what do we know actually. I think that gives us information about risks. I would probably try to triangulate what comes out of the AI. Not, I would like to, for instance, maybe also look at a Bayesian network for risk assessment. There's a big literature on that, and see if I use some well-known case studies, I will come to the same conclusions. So that's actually quite, I think, important. I very often start with a very skeptical view of the AI. So one of the first things that I tend to do before I even ask the question I'm interested in is I give it a question where I know the answer and see what the AI reports back to me on that. And then sometimes, most of the time, that is very, very uh, boring because it gives, of course, back what you would expect because it's there in the data. I mean, all the textbooks say the same thing. But occasionally you get sort of stunned a little bit. And on occasion, it also has made me sort of come back and think about, oh, did I actually read the literature correctly? Um, and then most of the time, it's sort of this kind of thing where I didn't give a proper boundary condition, and that's where the disagreement came from. But I think you should never take what the AI says as the final truth. It's an input, and so I would like to triangulate that. When it comes to policy questions, the key there too is, of course, is that there is a massive ethical responsibility on us. Not, I mean, if we're making a policy recommendation that is just completely wrong, um, that's that is something that we need to take ownership of. And because that is the case here, I would say, yes, you can trust a lot of the policy related research, but at the same time, you have to be a bit, um, bit sort of skeptical. And that's why I like to ask questions back. I often use the Socratic kind of method with AI, where it gives me an input and then I say, all right, well, what have you thought about this? Or if conditions were a little different, would you still think that? It's a bit of a weird relationship you build that way with a piece of technology, but it does sometimes gives you a sense where actually the boundary conditions are and what the premises are that the AI used to develop an answer, and that's what I would do with the policy related questions. Uh, um,
I think, sir, Mr. Sodegar has actually made just a remark.
yeah,
Yeah.
yeah, I think that's right. But I think it's actually an important point. Not, I mean, how much information can we still add? Have we sort of already reached the point of saturation? And I don't think we have, actually. I think there are massive blind spots still. And the other thing, that's the interesting experience I had last week as well, where someone put in a question, a prompt about food cultures in India, and sensible answers started to emerge. Then the person said, okay, well, now let's look at Northeast India. And that's where the hallucinations started. And these hallucinations were, in this case, not the consequence of bad prompting. It was just another boundary condition to a very useful prompt. But it was very clear that it just lacked the knowledge to do that. And so we do have to add to this knowledge base. That leads to some interesting problems, by the way, in terms of reproducibility of research. Not because that's been a huge topic in the social sciences, in medicine, in economics, where people have been talking about the half-life of findings being very short because nothing is reproducible. Um, Now there's reproducibility and reproducibility. I mean, the terminology should probably be more, can we, using the same data, using the same models, reproduce the answers that we got in the first place. And here is where that is already quite a tricky thing under a lot of circumstances, not because if I run an analysis, a statistical analysis, I almost have to containerize the whole thing because operating systems change, packages change, even the software that is the backbone for these packages changes. I could do that. That's fairly easy to do. But when you do that in the context of something like ChatGPT, if OpenAI decides that they're going to change the version of the software midstream in the middle of my research project, then I have a problem because I cannot tell people, hey, give these prompts and you will get exactly the same answer that I got. That will just no longer be the case. And we can't containerize any of it. It's proprietary. Will AI replace traditional marketing research instruments like surveys and focus groups or transform them? I really think it's more transformation than than replacement. I may be wrong about this. Maybe I'm underestimating this move towards the synthetic respondent. But what I've seen is actually in the domain of marketing in particular, a use of AI that actually makes, for instance, qualitative interviews more productive. So there is this survey company that is very active here in Switzerland called Bilendi. I think they actually also work in India. And they started to roll out about a year ago, they started to roll out this sort of new tool for qualitative research with a specific focus on marketing. And so here's what it is. It's a very simple setup. In principle, it took them a while to optimize it, but you sort of do two things. You say, okay, here's a question I would like to ask my respondents. And in the demo I saw, it had something to do with whether respondents, when they purchase clothing, actually pay attention to the environmental impact of the production of the clothing. And so that's a question that elder respondents get. But in the background, the software also has the research goals of the researcher, and not in the sense of what kind of answer do I want to get, but more in the sense of how much information about a particular topic do I want to get. And so what happens is that someone types in an open-ended response to this, and then the AI checks, is that enough? Is that the kind of thing that will satisfy the researcher? If that's not the case, then it comes back with a very polite prompt and says, listen, hey, please, give some more information. Particularly, can you speak more about this aspect? And then, at least in the demo, I don't know if that's still the case, the respondents very eagerly actually ended up providing some more information. And that is a very nice kind of routine, because that is something that you could have done with an interviewer, but the interviewer introduces a variable in there that can have actually quite interesting effects on the responses, not because people are guessing a little bit what the interviewer wants to hear based on some subtle signals they get. The AI has sort of a standard repertoire of things it will do to prompt for further information. So there's much less variability there. And that's an example of actually transforming things that we've been doing for a long, long time, what market researchers have been doing for a long, long time. I think it'd be harder to do in a focus group setting, but in these individualized, in-depth, semi-structured interviews, it's doable. I think that's the same with what you can do with the with surveys, not so you can ask follow-up questions. We've done this already in psychology and in educational testing. We've had these adaptive things. Not if someone tells you 5 times the right answer to a very complex math problem, then maybe you don't need to ask them the answer to 2 plus 2. They will probably get it. So there's this more adaptive testing. I think that's what we're going to see in survey research, where the AI is going to figure out patterns in responses and say, hey, but this sort of is a strange response in light of the other things. So maybe this person can elaborate on that. And that's, I think, what will happen before we really start to replace these traditional instruments. So, did I miss questions?
No, sir. Sir, actually, there is one question being sent directly actually to me. It is by
Mhm.
Abhishek Sharma. He asked, how relevant and reliable is the use of synthetic data in contemporary research?
In what sort of research? Secondary?
In contemporary research, the relevance and reliableness of synthetic data in contemporary research.
Okay. Yeah. I don't know the answer to intertemporal. I should actually see if there are even studies on this yet. But what I can say is that there is a paper that I just saw pass by at a conference where someone looked at experimental designs. And so basically, these experiments had been done in a variety of contexts. And it had a certain effect, not sort of an effect size on the survey responses. And what this person did, she actually then said, okay, let me now construct artificial respondents. So basically, she looked at the age distribution in the survey, the gender distribution, some mix of characteristics, and then she basically asked the AI to come up with responses for each of these groups and to see whether she could replicate these effects. And the remarkable thing is that actually she could to a considerable extent. There were a couple of exceptions, but in many cases, the artificial respondents actually behaved rather like the real respondents. And that's, I don't know what to make of that result. On one hand, I think maybe people are more predictable than we sometimes think. On the other hand, maybe it also says a lot about these experiments that we've been doing because maybe they're so obvious that it's easy to predict what will happen. Um, it's also not entirely clear how these predictions then come about for these synthetic respondents. Not, I mean, to what extent are you basically picking up on AI thinking, okay, well, there's a particular um, a particular expectation on the part of respondents of what the researcher wants to see, and it's just that is so obvious that the artificial respondents are sensitive to that. Um, so intertemporal will be quite interesting, of course, because now it depends a little bit on how long you want to stretch the time horizons. But I would imagine if you start to do this over longer swaths of time, it might not work out so well. Um, But that's a very interesting topic for further research, I would actually say. I would love to actually to look into that. If you sort of take a respondent, say a Swiss respondent from the 1990s, and you would do a synthetic version in of that respondent, and you would make a synthetic version of a respondent in 2026, how well do we still then pick up what we find in the real survey data? Because there it gets interesting because response rates have been very dynamically moving. Not in the 1990s, it was still quite high in Switzerland. Now it's pretty miserable. So there's more selection bias effect. So I could imagine that the AI might struggle with that to some extent.
Yes, sir. I think, sir, there are no more questions, so we can
Okay.
maybe move ahead with the program. Now I
Yeah,
would like,
perfect.
yes, now I would like to call Dr. Rishabh Gupta, Deputy Coordinator IQAC, to deliver the vote of thanks.
Thank you
Yep.
so much, sir, for your insightful and thought-provoking session. We are grateful for the time, wisdom, and clarity you brought to this session. I know, despite of your busy schedule, you were able to join us today. So thank you, sir. I'm also would
Great.
like to say a very special thanks to our principal, Professor Arun Kumar Atri, for his constant support and guidance. It would
Yep.
not have been possible without his kind willingness to organize such kind of interactive webinars. I also take this opportunity to convey my special thanks to Professor Varinder Kumar, under whose exemplary leadership and guidance this webinar was successfully conducted and attracted a huge participation and attention. I am also thankful to Professor V.A. Veeraman for his guidance in the successful execution of this program. Heartfelt thanks to our moderator and college alumni, Mr. Pratyush Sinha, who flawlessly organized this session. Special thanks to our technical team, Mr. Shubham and Mr. Rajneesh, for providing necessary technical guidance. And again, at last, special thanks to all the participants who joined us and made this interactive session a much more vibrant and meaningful. Thank you.